Have you ever looked at a tall building and wondered how architects figure out the exact angles needed to make it stand upright and strong? The precision and accuracy required in such constructions are nothing short of remarkable. Every angle, every measurement, and every calculation plays a crucial role in ensuring the stability and safety of these towering structures. Or perhaps you've marveled at the way airplanes navigate across vast distances, reaching their destinations with pinpoint accuracy. Pilots rely on a deep understanding of angles and distances to chart their courses, ensuring that they can fly safely and efficiently from one point to another. This isn't just guesswork, it's a precise science. The answer, my friend, lies in the fascinating world of trigonometry. This branch of mathematics is the key to unlocking these mysteries. It provides the tools and formulas needed to understand and calculate the relationships between the sides and angles of triangles, which are fundamental to so many aspects of our world. Trigonometry is like a secret code that unlocks the mysteries of triangles. Whether it's the design of a bridge, the structure of a building, or the flight path of an airplane, trigonometry is at the heart of it all. It helps us understand how different elements come together to form a cohesive and functional whole. Don't worry, it's not as intimidating as it sounds. Once you get the hang of it, you'll see that trigonometry is not only useful, but also incredibly fascinating. It's like learning a new language that allows you to see the world in a whole new way. It's simply a branch of mathematics that studies the relationships between the sides and angles of triangles. These relationships are not just abstract concepts. They have real-world applications that can be seen all around us. From the natural formations of mountain peaks to the man-made structures of bridges and buildings, triangles are everywhere. And trust me, these relationships are more important than you might think. Engineers and architects use trigonometry to ensure that their designs are both functional and aesthetically pleasing. Without it, many of the structures we take for granted would not be possible. Trigonometry pops up in countless areas of our lives. It's not just limited to construction and aviation. It plays a role in fields as diverse as music, physics, and even video games. The principles of trigonometry help us understand sound waves, light waves, and even the mechanics of motion. From architecture and engineering to music, physics, and even video games, this powerful tool helps us understand and shape the world around us. The next time you play a video game, think about the complex calculations that make the graphics and movements so realistic. That's trigonometry at work. This powerful tool helps us understand and shape the world around us. Whether you're designing a new building, navigating an airplane, or simply trying to understand the world better, trigonometry is an invaluable resource. So, buckle up and get ready to dive into the exciting world of trigonometry. You might just be surprised by how much you enjoy it. With a little practice and curiosity, you'll soon see the beauty and utility of this amazing branch of mathematics. Before we embark on our trigonometric journey, let's make sure we're all on the same page about the basics of triangles. Triangles are one of the simplest yet most fundamental shapes in geometry, and understanding them is crucial for grasping more complex concepts later on. A triangle, as you probably know, is a three-sided polygon with three angles. These angles can vary, but the defining feature is that there are always three sides and three angles. We often label the vertices, corners of a triangle, with capital letters like A, B, and C, and the sides opposite those vertices with lowercase letters A, B, C. This labeling helps us easily refer to specific parts of the triangle when discussing its properties. Now here's a fundamental fact about triangles. The sum of all three angles in any triangle will always be 180 degrees. This is true regardless of the type of triangle, whether it's an equilateral, isosceles, or scalene triangle. That's right, no matter how big or small, skinny or wide, the angles inside a triangle will always add up to 180 degrees. This property is what makes triangles so unique and interesting to study. This simple truth is a cornerstone of geometry and will come in handy as we delve deeper into trigonometry. Understanding these basic properties of triangles will provide a strong foundation for exploring more advanced topics, such as the relationships between the sides and angles in trigonometric functions. Let's meet the first of our trigonometric heroes, sine. This mathematical function is a cornerstone in the world of trigonometry and plays a crucial role in various fields, from engineering to physics. Often shortened to sin, pronounced like sine, sine helps us figure out the relationship between an angle in a right triangle and its opposite side. It's a fundamental concept that allows us to understand and solve many real-world problems involving angles and distances. A right triangle, you ask? That's just a triangle with one right angle, a 90-degree angle. This type of triangle is special because it allows us to use trigonometric functions like sine to explore its properties. Imagine you have a right triangle, and you know the length of the hypotenuse, the longest side, and the measure of one of the acute angles, an angle less than 90 degrees. With this information, you can use the sine function to find the length of the side opposite the given angle. The sine of that angle, written as sin angle, is simply the ratio of the length of the opposite side to the length of the hypotenuse. This ratio is a powerful tool that can help you solve for unknown sides and angles in right triangles. In simpler terms, sine tells you how tall the triangle is compared to its longest side. By understanding and using sine, you can unlock a deeper comprehension of the geometric world around you, making it an invaluable skill in both academic and practical applications. Next up is cosine, often abbreviated to cos. Cosine is all about the relationship between an angle in a right triangle and its adjacent side. Just like sine, we calculate cosine for one of the acute angles in the right triangle. The cosine of an angle, written as cos angle, is the ratio of the length of the adjacent side to the length of the hypotenuse. In other words, cosine tells you how long the triangle is along its base compared to its longest side. Section 5. Tangent, bridging the gap in triangles. Last but not least, we have tangent, often shortened to tan. Tangent focuses on the relationship between the two legs of a right triangle, specifically the opposite side and the adjacent side. The tangent of an angle, written as tan angle, is the ratio of the length of the opposite side to the length of the adjacent side. Think of tangent as a way to connect the height of the triangle to its base. Section 6. The unit circle, your trigonometric compass. Now that we've met sine, cosine, and tangent, let's explore how they relate to the unit circle. The unit circle is like a magical map that visualizes the values of sine, cosine, and tangent for different angles. Imagine a circle with a radius of 1 unit centered at the origin of a coordinate plane. As we move a point around the circumference of this circle, the angle formed between the positive x-axis and the line connecting the origin to the point changes. The x-coordinate of the point represents the cosine of the angle, while the y-coordinate represents the sine of the angle. Section 7. Real-world wonders trigonometry in action. Trigonometry isn't just confined to the pages of textbooks, it's all around us. Let's uncover some captivating examples of trigonometry in action. Architects use trigonometry to design sturdy structures, calculating angles and lengths to ensure stability. Engineers rely on it to build bridges, roads, and tunnels, factoring in slopes, distances, and load capacities. Navigators use trigonometry to chart courses, determine their position, and estimate arrival times. Even musicians benefit from trigonometry, as sound waves can be represented as trigonometric functions. Section 8. Conquering challenges. Practice makes perfect. Mastering trigonometry, like any new skill, requires practice. Don't be discouraged if you encounter a few bumps along the way. That's completely normal. The key is to approach problems systematically, break them down into smaller steps, and not be afraid to ask for help when needed. Seek out additional practice problems in your textbook or online. Work through examples step by step, understanding the reasoning behind each step. Join a study group or find a tutor to reinforce your understanding. Section 9. Embracing the power of trigonometry. As you delve deeper into the world of trigonometry, you'll discover its elegance, its logic, and its sheer power. You'll learn to solve complex problems involving triangles, circles, and waves, gaining a deeper appreciation for the mathematical principles that govern our universe. Embrace the challenge, stay curious, and never underestimate your ability to learn and grow. With dedication and perseverance, you too can master the art of trigonometry and unlock a world of possibilities.